Good evening friends, my name is Satyajeet Sahu and welcome to 2020 series. Okay, so this is a very short series, 2020 series, because the 2020 World Cup is going on. So we are connecting this particular session to give you an idea of the question which can be asked in the upcoming GATE 2023 examination. So this series is for what? Top, we can say, most expected 20 questions. But actually speaking, 20 questions will never be enough. Actually, truly, 20 questions can be asked from only one topic only. Yes. So actually per subject you have to practice more than 500 questions so that you can be able to score good in the examination. But yes, that 500 questions starts with one question, then second question, and 20 questions, and then further, yes. So therefore, this will act as a practice and also will give an idea of the level of the questions for upcoming examination. So today we're going to see what? Fluid mechanics. Today we're going to see what? Fluid mechanics. My name is Satyajeet Sahu. I have done my B.Tech and M.Tech both from IIT Kharagpur. I have cleared GATE with a good rank, and also I have been selected into many of the PSUs like Indian Oil, HPCL, RITES, and Delhi Metro Rail Corporation. And I have worked there for 2 years. I have teaching experience of more than 10 years in GATE ESE domain. So let us start the lecture. So welcome. Good evening, good evening, good evening. Okay, engineering Puspendra engineering sir, depths में पढ़ाना है, depths से पढ़ना है. Yes, depths में पढ़ना है. So पढ़ाई करने का time पहले था. So now time to practice questions. So this is for questions. Let us start the questions. So welcome all the participants. Let us start the question. So the first question, okay. So first questions, I will be solving 10 questions, and 10 questions I will be giving as homework, whose answer will be there. So you have to solve them yourself, okay? And if you need some help, then what to do, I will tell you at the end. Let us start the question, okay? So first question is, okay, this is the first question. What is this first question? U is given. U is given to us. Means what? The velocity equation is given. And the U is a function of what? Y. What is Y? If we have a fixed boundary like this, if we have a fixed boundary like this, and there is fluid motion. If we have a fixed boundary like this, and there is fluid motion, okay, so we are seeing what? We are seeing the velocity at a distance how much? Y. The distance how much? Y from this fixed boundary. So Y is what? Y is the distance from the fixed boundary, and the velocity is a function of this. So that particular velocity profile is given. The dynamic viscosity is given. It is given how much? 5 poise. Then the shear stress at a distance of 0.05 meter from fixed boundary. Okay, so concept nahi aata hai. So for that, there are many lectures which are conducted. There are many lectures which are conducted. The concept is already covered in those lectures. You can refer those lectures and then come back to solve these questions. Okay. So Y is equal to 0.05 meter. This Y is given. Yes, this Y is given. They are asked what? The shear stress. The shear stress. Now what is the equation of shear stress? The equation of shear stress is dynamic viscosity into what? Du by dy. This is what? This is your Newtonian law of viscosity, right? This is the Newtonian law of viscosity. And this is known as what? This is known as velocity profile. Okay? Velocity profile. Okay? Now, velocity gradient, sorry. Velocity gradient. The profile is already given. So we can find this, right? We can find this velocity gradient. How? We can differentiate this. Du by dy. I'll differentiate it. You see, this is the equation of U. So if I differentiate it, you see already 5 is there. Then I'll differentiate this sine term. So differentiation of sine term is what? Cos term, right? Differentiation is cos term. So this will be how much? 5. When I differentiate, it will become how much? Cos 5 pi y. And this 5 pi will also appear, right? That is the rule of differentiation. Okay? This will also appear here. Yes? So this will be what? This will be the du by dy. Right? Now here what I will do, I'll put y is equal to how much? I'll put y is equal to 0.05. Okay, I'll put y is equal to 0.05. Many students have answered, so let me just check that you have solved it correctly or not. Okay, some people are asking some things. Mil jayenge kya FM ke? Okay, yeah. They are available. They're also available in the app. Okay, let us solve this. So when you put y is equal to 0.05, this will become how much? 5 into 0.05. That is 0.25, right? So 0.25 pi is what? Pi by 4. So this becomes how much? 25 pi cos pi by 4 will be what? Root 2. 25 pi by root 2. Yes, so this is the velocity gradient, I can say. But we have been asked what? The shear stress. Yes, so how to find out the shear stress? The shear stress will be equal to the dynamic viscosity, how much? 5 poise. Now see, 5 poise is how much? 5 poise is equal to, if we convert into standard units, it is 0.5 Newton second per meter square. Remember this, that 1 poise is 0.1 Newton second per meter square. Very good. So this is 0.5 and the velocity profile, how much we got? 25, gradient 25 pi by root 2. Yes. So I can solve this and get the shear stress value, right? Let me solve this. 25 into pi into 0.5 divided by root 2. I'm getting 27.76. I'm getting how much? 27.76 Newton per meter square. So yes, Nikki has got 27.75. Some other students solved, but somehow some mistake happened. That is fine. You are learning. No problem. Yes. So we understood how to solve this question. So in this examination in GATE, this is a very standard question. It's a very standard question. What they will give? They will give you the function of u. They will give you the function of u. Yes. So if they give the function of u, you can always find out what? Du by dy. See, here it is a trigonometric function. It can be a exponential function. It can be an algebraic function, right? Any function they will give. So you can always differentiate it and put the value of y given. Put the value of y given. Now once you find this, the shear stress will be how much? Simply dynamic viscosity into what? Du by dy. Okay. So lectures are available in the YouTube channel. You have to search. Okay, lectures are available in the YouTube channel. You have to search, and also they are available in the app. If you download the BYJU'S Exam Prep app, there also lectures are available. Okay. Okay. So first question is over. First question is over. Let us go to second question. Okay, let us go to second question. Okay, the second question is from what? From viscosity only. This is from viscosity. It's a standard question which they ask a lot. Standard question which they ask a lot. So rectangular plate is there. The dimensions are given. This means what? This is the area, right? This is the area. Then the weight is given. Yes. And also it is on an inclined plane making 30 degree. Making what? 30 degree to the horizontal. And the particular plate is sliding down with a particular velocity. It is sliding down with a particular velocity, and that velocity is given how much? 1.75 meter per second. Now this particular gap, yes, there is a gap because there is a fluid. On this particular inclined plate, there is a fluid. On top of that, there is a plate. Now this fluid has a gap, or we can say this gap is filled with a fluid, right? We can say like that. It is 2 mm. It is 2 mm, and here this fluid is an oil. It's an oil. And this oil will have a particular viscosity mu. We don't know, that is not given. Okay, that is not given, but we can find out. And that is what is asked here. That is what is asked. Now what is the theory behind it? Let us put some light. What's the theory behind it? Now, if this particular plate is sliding down, why it is sliding down? Because there is weight, yes, and there will be weight components, right? There will be weight components. If this is theta, this is also theta. And I can say this will be, if this is W, the weight, this will be W cos theta, and this will be W sin theta. Yes, this will be W sin theta. So due to this particular weight component, this particular plate will slide down at a velocity v. At a velocity v. Okay. Now we know that the Newtonian equation is what? Of shear stress. That is, shear stress is equal to mu into du by dy. Du by dy. So what is du by dy? Du by dy is equal to, I can say, the change in, okay, this engineering Puspendra, the lectures are available in the app. Download the BYJU'S Exam Prep app. There you will find lectures. Now please Okay, please focus on the lecture. This, if you are finding it difficult, you can go to the BYJU'S Exam Prep app and there you can see the lectures. Sir, are you using a tablet or laptop to draw diagrams? How does it matter to you? You have come to see that, I am using tablet or laptop. How does it matter to you? You are here to investigate that, or you are here to learn the lesson. So this is change in velocity by what? Change in distance. This is change in velocity by change in distance. Yes, dy is what? Change in distance. Du is what? Change in velocity, right? Now see, if you see a fluid particle here, it is attached to the plate. It is attached to the plate. So it will be moving also in the speed v, right? It also will be moving at speed what? V, because it is attached to the plate. Yes. Now, a particular fluid particle which is here, which is attached to the inclined surface, that inclined surface is at rest. So I can say that the fluid particle will have velocity how much? 0 there. So here the fluid particle is having velocity v, and here means the 2 points, they are having velocity 0 and v. So can I say that this change in velocity is how much? V minus 0. This is the change in velocity. Now change in distance is how much? Change in distance is this one, right? And suppose that I am calling as h. Change in distance is at h, right? So I can say the change in distance is how much? Dy is equal to how much? It is h only. Okay? It is h only. Okay. Your diagrams are really neat. Thank you for the compliment. That, I am drawing in the tab. I can show this. Okay? But thing is that everybody can't do it. That requires a lot of practice and skill. Thank you for the compliment, by the way. Okay, so v minus 0 is the du and dy is what? It is the h. Dy is h. Now, so here I can write down shear stress is what? Mu into v by h. Yes, very good. So this I can say is the shear stress we got. Now what is the force? This is the stress, right? Now what will be the force? The force will be simply what? The force will be simply what? Mu v by h, which is by the way what? The shear stress into plate area. Yes, so I can write down mu v by h into area. So this will give me what? This will give me what? The force. Now here what is the force? What force is driving this particular plate? That is v, this w sine theta, right? So this is the force. And that particular expression we got here. Yes, so I can say the expression is what? The force w sine theta, which is responsible for movement of this particular plate, that I will equate into shear stress into area. That is what? Mu into v by h into area. Okay? Okay. क्या पढ़ना है? Okay. Somebody is writing, sir, college students से कुछ पता नहीं चल रहा है, क्या पढ़ना है? Okay. You download the app. In the app, you start with lecture number 1. In the app, you go to fluid mechanics, you start with lecture number 1. So if any time you feel that where to start, so what you should do? Go to chapter number 1, lecture number 1, start from there. Understood? Any subject you are starting and you don't know where to start, simple logic, go to chapter number 1, lecture number 1 and start from that lecture. Okay. Now coming back to this. This is what? This is we got. What? This we got the expression. Everybody understood the expression? Easy, right? Now we'll use this expression and I will solve this question. So w sine theta will be equal to what? Your mu v by h into area. See, area is how much? 0.5 into 0.5. That is what? 0.25 meter square. This is your area. This is velocity, right, of the plate given. Now h, the gap is given how much? 2 mm. This is h. So I'll convert into what? Meter. So 2 into the power minus 3 meter. Everything I'm converting into meter. Now W is also given 500 Newton. So this is, I can say, W, right? So if you put all these values, can you give me the value of mu now? Put all these values and give me the value of mu. Put all these values and give me the value of mu. Solve this. And since everything is in standard units, I'll get the value of mu in what? Newton second per meter square. So put these values. From here I can say mu will be how much? W sine theta into H by V into A. So put all these values and give me the value of mu. Let me see who is solving first. One 1.1114, 1.114 you are getting, very good. So you are getting 1.1143 I can say, right? 1.1143 you are getting. Okay. Now see this thing. Now see this thing. What happened? What happened to my phone? Goom goom. Okay, no problem. So this is mu. Now what they have asked? They have asked the viscosity in poise. So how to convert? Multiply by 10, right? Remember that 1 Newton second per meter square is equal to 10 poise. Is equal to 10 poise. So this will be how much? 11.43 poise. Understood? So this is a very simple question which they can ask in the examination. And you see in this equation, see they have asked you the viscosity. They might give you the viscosity and ask you the weight. Yes, they might give you the weight, they might ask you what? The velocity. They might give the velocity, they might ask you what? H. They might ask you area, they might ask you anything. They might even ask you what? The inclination of the inclined surface. Okay, so this is another question from viscosity. Let's go to the next question. Question number 3. Let us go to question number 3. And question number 3 is from manometry. This is from what? Manometry. Okay, so this is a point A. This is a point A. And this is a point B. Okay, so the pressure at A is given. The pressure at A is given as 1.05 kgf per centimeter square. So it's not that kgf. Okay, there's something else kgf. And the pressure at B is given as 1.75 kgf per centimeter square. So these two values are given to us. Okay, and what is asked? You have to find this x. You have to find this x. Now how to find this x? Very easy. In manometry, I will give you one hint or tip I can give. In manometry, when you are solving any question, okay, remember two things. The first principle of manometry is that the pressure at same level in same fluid is same. That means you take this level. You take this level. And suppose I am taking 2 points here, sorry. Suppose I am taking 2 points here. Suppose this is point number 1 and this is point number 2. Right? Now you can clearly see that these 2 points are at same level, right? These 2 points are at same level. Suppose this point is M and this point is N. So these 2 points are at same level. Very good. Okay. And they are in the same fluid. You can see they are in the same fluid, this black fluid. This black fluid which is having specific gravity of how much? 13.6. Right? Specific gravity of how much? 13.6. Yes. So this 13.6 is specific gravity of what? It is of mercury, right? Yes. So I can say this M and N. Okay. This Mn is in what? Is in mercury. Okay. Black mercury. Okay. And therefore I can say the pressure at M will be equal to the pressure at N. So this is what important conclusion we should always remember. Now the pressure at M is equal to the pressure at N. No problem, very good. Now how to reach to this point M? You see, we can go from this point M from A level, right? You see, this is the level and here the pressure is PA. Now when you go below, okay, or we can say down a particular fluid, the pressure will increase, okay. You can see that if you want to go from this point to this point, see here pressure will be same because same level, right? So if I want to find out the pressure here, what I have to do? I have to take this distance into consideration. That is how much? PDF मिल जाएगा क्या? क्या करोगे PDF का? क्या करोगे PDF का? please now don't disturb. Actually, you are disturbing the class. Okay, whatever you want to ask at the end. Now, if you want to have any doubt, you can ask from the questions which I'm solving now. Okay, so if you have any questions, ask from the questions which I'm solving now. Don't ask such questions in between. Okay, now you will start asking many things. I cannot answer those questions in the middle of a particular explanation, right? Okay, okay. PDF. PDF का क्या करोगे? What you will do with the PDF? Now people ask me, give PDF. What you will do with the PDF if you don't know the theory behind it, the explanation behind it? Better is to listen to that lecture, understand the lecture, solve the questions. Instead of doing that, you are collecting the PDF. What you will do by collecting the PDF? What you will do with the collecting the PDF? Tell me. Will you submit the PDF in some office and they will give some marks? GATE is conducting, examination. They will ask you, whoever has maximum PDF, they get some special marks. No, na. So focus on the learning. The lectures are there in the channel. So better understand how the questions are solved. See those videos. Okay, if you have doubt, you can always, I told you that you can visit the app and, start from the chapter 1 or whichever topic you want to start. Instead of focusing on that, you want to get the PDF. What you will get from the PDF? Okay? What you will get from the PDF, man? What you will get from the PDF? Huh? How the PDF is going to help you if you don't have the understanding of the subjects? Okay? This is, I can say one of the major problem with many of the students. They're collecting PDF resources from many points. They're collecting, don't feel bad about it. Okay, but it is, I'm telling you for your own good, that people go here and there, they go to this channel, that channel, and then, they'll ask PDF, they'll collect the PDFs. Earlier in our times, also students used to collect notes. Okay, they will connect notes, this much notes. Okay, so notes, so many notes are there, but what will do with the notes or PDF or book, whatever? If you don't know that, what is the concept behind it, what you will do with this? So better focus on the concept. Don't run after this PDF. I know the subjects, then PDF will help. Okay, you know the subjects. You know the subjects? Okay. So, if you know the subjects, first of all, you know the subjects. You're asking, so let us have a discussion. Okay, let us have a discussion. Somebody is asking about subjects. Okay. PDF help करते हैं. कैसे help करते हैं? कैसे help करते हैं? बताइए. कैसे help करते हैं? बताइए. You are telling that you don't know. For somebody, कुछ पता नहीं चल रहा है क्या पढ़ना है. आपको पता नहीं है क्या पढ़ना है, and you know that which PDF will help you how. If you know, then solve this question and tell me the answer. If you know, then solve this question and tell me the answer. You, instead of focusing on the particular question, you are collecting PDFs. And now, Jitin is telling that I know something PDF will help. Okay. Now tell me why you are so lazy that you cannot write down the questions. Why you are so lazy? Why you want everything gifted to you? Why you can't write down the questions? And first thing is that why I will provide the PDF? Am I obliged to give you PDFs? Am I obliged to give you PDFs? When the lecture is conducted and so many questions are solved, why can't you just write the questions? I'm too lazy. That is the problem. If you feel that you are too lazy, then you can't clear the examinations. If you're too lazy, then you can't clear the examinations. If you want to be active, write down the questions. We used to write down the questions. Earlier people have write down the questions. Write down the questions, solve the questions. Any of the videos are available. And you are telling, we want the PDF. Many people tell we want the PDF. Okay, it's okay. Technology is so good, you can just take screenshot of the questions and you can form the PDF within 2 minutes. You can take screenshot of the questions and you can form the PDF within 2 minutes. Students are doing that. They're very smart. You are lazy and you are unsmart also. That that you cannot take screenshots and you can form a PDF. PDF makers are there. It hardly takes 2 minutes. So you expect the teacher, he will teach. Okay, the teacher is your servant. You feel the teacher is servant. Teacher will come, teacher will frame the questions, teacher will draw the PPTs, teacher will teach you also. Okay, and then he will give you PDF also, he will give the exam also. No PDF, sir, only live study. Okay, focus on live study then. Okay, so don't be lazy. Come on, don't be lazy and be smart. Students are smart, they are doing many things. Okay, So I want to discuss this because many students ask for PDF and all, and it's waste of time. Okay, come on, so let's solve this question. So the pressure at M and pressure at N is same. Okay, so how to find out the pressure at M? You see, to find out pressure at M, okay, I have to go down 4 meter in this fluid and then X meter in the other fluid. And how we find out this? So I can say the pressure at M will be equal to the pressure at A plus, this is 4 meter, right? 4 meter, yes, 4 meter. And what is the unit weight? What is the unit weight of this particular fluid? This pink fluid. This pink fluid is having a specific gravity of how much? 1.6. So I can say to find out the pressure increase, what I will do? This is the depth and then 1.6, the specific gravity into gamma W will give me the gamma of this pink fluid. Will give me the gamma of pink fluid. Yes. See, pressure is what? Gamma into H. Gamma into H, right? So H is 4 meter. And how to find out gamma of this pink fluid? Simply, this simply is what? The specific gravity into gamma W. Easy. 1.6 into gamma W gives me what? The gamma of this particular fluid, and I multiplied with 4. Then you see what is there. Then what is there? Then we have X meter of this black fluid, mercury. Yes, mercury is there. So there will be further increase. The H is X meter, and what is the gamma of mercury? This will be 13.6, the specific gravity into gamma W. Okay, and this will give me what? The pressure at M. Understood how I'm finding the pressure at M? Very easy, very easy. So pressure at A, yes, then this increment and this increment. Very good, nice. Now coming to the pressure at N. How to find out the pressure at N? Very easy. For that I will go from this side, B. Okay, so you see at this level, the pressure will be same, so this is pressure at B. Now from B to N, if I want to go, I will go this much distance down. Right? This is how much? This I can say is 1.5 plus X, right? This 1.5 into X was plus X, and the fluid density is how much? 0.8. So I can say that Pn is equal to Pb plus the depth is how much? 1.5 plus X, and the gamma of the fluid is how much? Specific gravity into what? Gamma W. Yes. So these two pressure expression I found out. So I'll again write down this. Pm and Pn. So Pm is equal to Pa plus 1.6 gamma W into 4 plus, this is M, right? Yes. And then your 13.6 gamma W into X. And this is equal to Pn, which is equal to how much? Pb plus 1.5 plus X, then 0.8 into gamma W. I can open this bracket. This will be what? Pb plus 1.5 into 0.8 will give how much? 1.2 gamma W. Okay, 1.2 gamma W it will give me, right? And then plus, what I will get? I will get 0.8 X gamma W. Very good. Now see, I told what? This M and N are at same level, in the same fluid. So these two pressures will be same. These two pressures will be same. Yes. So equate both of them. Let us equate both of them. So if I equate this expression and this expression, I can equate. So I can say that Pa plus, this is 1.6 into 4 is how much? 6.4, right? 6.4 gamma W plus 13.6 gamma W into X is equal to Pb plus 1.2 gamma W, yes, plus 0.8 X gamma W, 0.8 X gamma W. Now what I will do, I will take these two terms this side and I will take this term this side because I have to find that X, right? So what will happen? 13.6 minus 0.8, yes, 13.6 minus 0.8 give me how much? 12.8x gamma W is equal to PB minus PA, right? PB minus PA, then 1.2 gamma W, and then minus 6.4 gamma W. This 1.2 gamma W minus 6.4 gamma W will give me how much? Minus 5.2 gamma W. Easy. This much everybody understood. So now I can easily find out X, but I need this PB minus PA. You see, that was given initially, right? PB was given how much? 1.75 kgf per centimeter square, and PA is given how much? It is given 1.05 kgf per centimeter square. Now see, PB minus PA is how much? Can I say it is 0.7? Yes, it is 0.7. Okay, 0.7 kgf per centimeter square. Now, what is this kgf per centimeter square? What is this kgf per centimeter square? Now, kg force, it is the force exerted by 1 kg. So, what is the weight of 1 kg? That will be 1 kg into 9.81 meter per second square, right? mg, right? Mass into the acceleration due to gravity, right? So, this is the force due to 1 kg mass. Okay, so force due to 1 kg mass is how much? mg. Yes. So this divided by, you see, this is this kg meter per second square is how much? That is 1 Newton, right? Kg meter per second square is Newton, right? Then divided by centimeter square. Now 1 centimeter square is how much? 10 to the power minus 4 meter square. Yes. So this will give me how much? If I take this up, I'll get what? 10 to the power 4. So 9.8 in 10 to the power 4 Newton. Now see, this can be written as 10 kilonewton, right? 10 to the power 4 can be written as what? 10 to the power 3. Yes. So it becomes kilonewton, right? Now see, this 9.8 is actually gamma W, right? It's actually gamma W, right? Yes. Very good, Karthikeya. It's gamma W, right? So I can say this is nothing but this 1 kgf per centimeter square is nothing but what? It is 9.8 gamma W kilonewton per meter square. Now why I am converting to kilonewton meter square? Because everything is standard units. Okay, that's what I am converting. Okay, very good, very nice. Yes. So now you see, I'll erase this now. I'll erase this. So this PB minus PA, I am getting how much? If I subtract, I am getting 0.7 kgf per centimeter square. Now this 0.7 kgf per centimeter square, I can convert what? Sorry, this is actually, sorry. What I wrote, 1 kgf per centimeter square actually will give me what? 10 gamma W, sorry. Because gamma W is 9.8, this is 10 gamma W. Yes, 10 gamma W. So what I will do, 0.7 into this kgf will be converted into what? 10 gamma W. And then minus 5.2 gamma W. This is what? 7 gamma W minus 5.2 giving me how much? 1.8 gamma W. Now can you give me X? Now can you give me X? Find out X and give me. Find out X and give me. Okay. Find out X and give me. How much are you getting? X. Are you getting? 0.141 meter. I'm getting how much? 0.141 meter. So from this question, which is a standard question for GATE, we understood that you cannot just crack GATE by, collecting some PDF. Write it down in a piece of paper. Okay, paste in your walls. You cannot crack GATE or get a good rank in GATE by just collecting some PDFs. You have to understand the concepts. Like this in fluid mechanics, there will be 500 concepts. This is one of the concepts. This is just one of the concepts. There are 500 concepts like this. And you have to understand that from a experienced teacher like this. Otherwise, you can also study yourself. You will also crack. Yes, you have to open the books and study from there. From books also you can study. That is also a good source. But by collecting PDF from here and there, nothing will happen. Okay. So this question everybody understood. Let us go to the fourth question. So 3 questions are over in 40 minutes. Yes, you can see that the questions for GATE are not going to be easy. The questions for GATE are not going to be easy. So let me see the comments here. Some, I'm seeing comments. I want to see my mobile. Are they coming or not? Okay. Okay, very good. Okay, very good. Nice. Okay. Chalo, let us solve the next question. Fourth question. Okay, so something on what? Something on the buoyancy. Something on buoyancy. So we have a metallic body which floats at the interface of mercury. So we have here mercury, okay, and then we have here what? Water. We have water over here, okay, and it is written that the 40% is submerged in the mercury. Okay, very good. 40% is submerged in the mercury and 60% is in water. Okay. Now mercury has a specific gravity of how much? 13.6, and obviously water has a specific gravity of 1, right? We should know that. Okay. Now how to find out the density of this metallic body? Okay. How to find out the density of this metallic body? Okay. How to find out the density of this metallic body? How to find out? Let us see how to find out. Very easy. Now this can be solved by what? Archimedes principle. Now what is Archimedes principle? The Archimedes principle is the weight, okay, sorry, the weight, the buoyant force is equal to how much? It is the weight of fluid, displaced, okay, it is the weight of fluid displaced. Now see, this kind of question you cannot just solve by flukes. Okay, so don't imagine this to be some kind of, you know, akkad vakkad bambe exam. This is serious GATE. So don't think that you can just solve these questions by fluke. You need proper conceptual clarity to solve these questions. Okay, so the buoyant force is equal to the weight of fluid displaced. Now, how much fluid will be displaced? Whatever is the volume of this particular, we can say metallic body, that much fluid will be displaced. But there are two fluids. Suppose total volume of the metallic body, total volume of the metallic body is, suppose it is V. So I can say that in the water there is 0.6 V. In the mercury there is what? It is 0.4 V. It is 0.4 V. Very good, nice, beautiful. Now I can say that how much water is displaced? 0.6 B water is displaced. And how much mercury is displaced? 0.4 B mercury is displaced. Yes. So now if I want to find out the weight of this fluid displaced, what will be the weight of this fluid displaced? First, 0.6 V of water is displaced. So what will be the weight of this much of water? The volume into what? The unit of water. Yes. So I can say this is the buoyant force due to the volume of water displaced. Very good. Now, what is the buoyant force due to the volume of mercury displaced? That will be 0.4 V into the unit weight of what? Mercury. Now, mercury will have how much unit weight? The specific gravity into unit weight of water. So I can say these are the buoyant forces. You can say this is the first part and this is the second part, right? So I can say total buoyant force is this. Now this is the total buoyant force. Now buoyant force acts where? It acts upwards, right? So you can say this is the buoyant force in the first part and the buoyant force in the second part, right? Now this particular buoyant forces will be balanced by what? The weight of this particular body. Okay. Now what is the weight of this body? The weight of this metallic body will be its total volume into the unit of this particular metallic body, and the unit weight of this metallic body will be how much? Its specific gravity, which I don't know, into what? Into gamma W. Yes, very good. Now you can easily solve this question. Gamma W get cancelled. V get cancelled. Now can you give me the specific gravity of this metallic body? Can you give me the specific gravity of this metallic body? Tell me, what's the answer? What is the specific gravity of the metallic body you are getting? What is the specific gravity of this metallic body you are getting? Tell me. What is the specific gravity of this metallic body you are getting? Many people have solved to answer correctly. Very good, Kiran. Very good, Rishabh Goyal. What is the specific gravity? Is this metallic body specific gravity? Tell me. Please tell. How much you are getting? 6.04. Very good. You are getting 6.04. Beautiful. So now they have asked what? The density. So if they are asking you density in kilogram per meter cube, so we can find out the density of that particular metallic body as what? 6.04 into 1000, because water's density is 1000 kilogram per meter cube. So I'll get what? 6040 kg per meter cube. If they ask you in kilonewton per meter cube, so I can say that in that case, I can say it will be 6.04 into 9.81 kilonewton per meter cube. 9.81 kilonewton per meter cube. So how much will get this? Let us find out this. Okay. Very good, Mamta. I mean, many students have found very good, great. Thank you for your patient hearing and attending the lectures very sincerely. Thank you very much. Newton per meter cube. Okay. So we can say that we can solve this type of questions by using the simple concept of buoyancy. Let us go to the next question, fifth question. Okay, so let us go to something on what? Boundary layer and drag coefficient. Okay, so drag coefficient is asked. What is drag coefficient? It is CD. How to find out this drag coefficient? Let us see. See, we have a laminar boundary theory, laminar boundary layer whose thickness is given. Okay, so boundary layer thickness delta is given as 6 mm. Okay. And then the velocity profile is given that u by u, okay, is equal to sine pi by 2 into y by delta. What is y? Y is that same thing that, distance from the fixed boundary. Y is what? The distance from the fixed boundary. So from here I can say, okay, we'll get this relationship. What is this capital U? Is the stream velocity. Is how much? 15.5 meter per second. And u is the velocity at different, we can say, distances from the fixed boundary. So this is given. Now, I can find out the boundary stress, right? Why I'm finding the boundary stress? Because you see, we know this relationship. What is boundary stress? Boundary stress is half the drag coefficient into the density into what? U square. This is the expression, right? So if I can find out the boundary stress, this is what the boundary stress. Boundary stress means what? What will be the value of y at boundary stress? Is boundary, tell me. What will be the value of y, tell me, at boundary? Come on, tell me. What will be the value of y at boundary? What will be the value of y at boundary? So I want to hear also, some discussion also hoga. Very good, Ganesh, very good. So it will be what? It will be 0. So I can say at y is equal to 0, I can say, right? At y is equal to 0. So if I can find out the boundary stress, then I can find out this drag coefficient, right? By half of rho u square. Yes. So I have to find out this boundary stress. Now how will find out boundary stress? We know this equation, mu into du by dy, right? Okay, so mu is given to us, very good. Du by dy you can always find out, you see, this is the expression of u. So if you differentiate this, what you will get? Capital U. Then you see, when I differentiate this sign, I will get cos, and we can say that this y by 2 delta will come out, right? I can say this y by 2 delta will come out, so y by 2 delta will come out, yes. Then I'll get a what? Cos pi by 2 y by delta. So this will be what? Du by dy. Now we are interested in finding the boundary stress, so I'll take what? I'll take y is equal to 0. If I take y is equal to 0, it will become what? Cos 0. Cos 0 is what? What is cos 0? Cos 0 is 1, na? Cos 0 is 1, so I'll get this as 1. And this velocity gradient I will get how much? Capital U y by 2 delta. Yes, I'll get this expression. Yes, I'll get this expression. Very good. Now, I have got this expression. Now I can put here and I can find out mu is how much? 1.02 10 to the power minus 3, right? And then you can put this value u, okay, y will not come. Y you are differentiating. Sorry. Pi by 2. It will be pi by 2. Sorry. It will be pi by 2. You differentiate with respect to y. So it will be pi by 2. So put this expression and give me the value. Put this expression, give me the value of this boundary stress. Because you see, this is 6 mm, right? Delta is 6 mm. I can take in meter, 10 to the power minus 3. Everything is 100 unit. And u is in 0.15 meter per second. Give me this value. Come on. Give me this boundary stress. I will also calculate. 1.02, 10 to the power minus 3. Very good. And u is 0.15, and then pi, and then divide by 2, and then divide by 6, divided by 10 to the power minus 3. Reading 0.04. Okay, somebody has found. Rishabh Goel, very good, very good. You have found out the correct answer. So let me go there. So shear stress is how much? 0.04 Newton per meter square. This is the boundary stress you are getting. This we are getting what? The boundary stress. So we got the boundary stress, very easy. Now I'll put here and get the expression, right? So it is 0.04 Newton per meter square half. Everything I'll put in 100 units, so 1000, okay? And then u is given 0.15 whole square. So if you solve this, as our very dear Rishabh has found out, we are getting how much? We are getting around 3.56 10 to the power minus 3. This is the drag coefficient. It's a drag coefficient. Let me just take the value. Yeah, almost we are getting this value, right? Understood? A question on boundary layer theory, easy. So let's go to the next question. Question number 6. Ooh, question number 6. Another question on boundary layer theory. And you know what? Boundary layer theory. So many students have got. Oh, very good. Those students are finding the answers. That's great. Okay. Now we have a viscous laminar flow, and we have laminar boundary. So in laminar boundary, we know that if we are trying to find out the boundary layer thickness, okay, boundary layer thickness, what is the expression? It is 5x by root under REX. What is this? Suppose this is your fixed plate, okay, you can say, and the boundary, laminar boundary layer is formed like this. So if you are taking at distance x, yes, so this I can say, yes, yes, and this is a Reynolds number. Reynolds number is what? Reynolds number I can say will be root under rho v, yes, and then x by mu. So what happens, you see, this is root x in denominator and x in the numerator. So can I say that if other factors are same, suppose b is same, mu is same, can I say this boundary layer thickness will be what? Will be directly proportional to root x, right? It's a very important conclusion. You should know this, that this boundary layer thickness will be what? It will be directly proportional to what? Root x. Directly proportional to what? Root x. Very good. Directly proportional to root x. Yes. So now what is written, that at a particular length L, the thickness is something, delta L. Now when the plate length is increased to twice its original length, it is increased to what? Twice its original length, then what is the percentage change in the boundary layer thickness? Very easy. So can I say that since your delta boundary layer thickness is directly proportional to root x, yes, so I can say delta 1 by delta 2 will be what? Root under x1 by root under x2. So initially the length of the plate is how much? L. Now it is how much? It is 2L. Became twice, right? It became twice. So I can say delta 1 by delta 2 will be equal to 1 by root 2, or I can say that delta 2 is equal to root 2 times of delta 1. Yes. And the percentage increase in the boundary layer thickness will be what? It will be delta 2 minus delta 1 divided by what? Divided by delta 1 or delta 2? It will be divided by delta 1, because originally it was delta 1. It increased to delta 2. Okay. So into 100. Yes. So this will be, you can say that, sorry, delta 1, sorry, here. So I can say this is what? Root 2 delta 1 minus delta 1 by delta 1 into 100. So how much I get? I get 41.4%. Okay. And many questions, very good, very good, very good, Rishabh. And Ganesh, I'm happy that you all are seriously studying and solving the questions. Please continue such good thing. You will have great future. Okay. So this is what the boundary layer. Can say very important concept which we use in solving numericals. Okay, very good. Let us see the next thing. Question number 7. Okay, something on fluid kinematics also. Something on fluid kinematics also. Yes. This question is 4 here. This question is 4. So in incompressible flow, what should be the value of lambda? Okay. So in incompressible flow, if you use the continuity equation, in incompressible flow, if I use the continuity equation, yes, what is the continuity equation? The differentiation of u with respect to x plus differentiation of v with respect to y plus differentiation of w with respect to z is equal to 0. Now it is a 2D flow only because only u and v are mentioned here. So I can say this term is 0. Yes. Now differentiate this particular u with respect to x. This is u. If you differentiate respect to x, what I will get? The first term will be lambda into y cube, differentiating respect to x. Second term will be minus 2xy. Now dv by dy, you can see this term. Yes. So differentiate it with respect to y, it will be what? 2xy. And this is actually 3 by 4 y to the power 4. So differentiate it with respect to y, what I will get? 4y cube. So this 4 get cancelled. And this will be equal to 0. Very good, Rishabh. So from here you can say this also get cancelled. So what I get? Lambda minus 3 into what? Y cube is equal to 0. Okay, so y0 is trivial, you can say. So from here I can say the lambda is 3. Understood everyone? Understood everyone? Very good. So this is a question from fluid kinematics. So like this, many students might be thinking that where to solve other questions. So in the BYJU'S Exam Prep app, I will be giving 10 questions with the answers also. Okay. In the BYJU'S Exam Prep app, we have two type of things for your practice. One is there is practice questions. So you download the app, there are practice questions. There are subject-wise, chapter-wise practice questions like this. And solution is also provided there. So you can, see the solution also. You can text, you don't have to worry that, and you don't have to need PDF also. Why? Because those questions will remain in the app. So always you can go and visit. Yes. So practice questions are available. You can download the app. In that app, you can go to, suppose you want to practice fluid kinematics questions. So what you will do? You will go to the app, go to practice sessions, then go to fluid mechanics, then go to fluid kinematics, and then you can solve questions. Yes, you will get a lot of questions there to practice. Okay. Let us solve the next question. Question number 8. Okay. So we'll solve 10 questions and then 10 questions homework. So that, and the answer will be provided. Okay. The answer will be there. So you can always see. Question number 8. Okay. So something on what? Let us see something on, viscous flow. Viscous flow. Okay. Incompressible flow. Let us see something questions from there where we'll use our Hazen-Poiseuille equation. So an upward flow of oil is happening, you see. The upward flow of oil is happening. Yes. That means what? The flow is from this point to this point. Suppose this is section 1, this is section 2. So flow is happening from section 1 to section 2. Density is this. Dynamic viscosity is this. Okay. It is taking place under laminar conditions in an inclined pipe of diameter this. Suppose this is T. Okay. The pressure at point 1 and pressure at point 2 are given to us. Find the discharge in the pipe. It's a very standard question, discharge in the pipe. Now, we can apply Bernoulli between the point 1 and point 2. Okay, Bernoulli between point 1 and point 2. Now, this I can say, suppose, if I take the level of point 1 as the datum, so can I say Z1 will be equal to 0 because I am taking that as datum only, right? It will become 0. Now if I want to find out this Z2, okay, suppose this is 0.2, so this is Z2, yes, because this is datum, okay, so Z1 is 0, this Z2, is how I will find? Very easy. You see this is 5 meter, this distance is given 5 meter, and this is 45 degree, this is 45 degree, yes. So I can say this Z2 will be how much? This will be 5 by sine 45, right? This will be how much? 5 by sine 45, right? You see this will be how much? 5 by sine 45. Yes? Or 5 sine 45. 5 sine 45, right? This is 5 sine 45. Yes, or I can say 5 by root 2. This is what? 5 by root 2. Very nice. Now when I apply Bernoulli between point 1 and point 2, for point 1 pressure head will be P1 by the gamma of oil, yes, plus V square by 2g, V1 square by 2g, the velocity head, and then Z1, right? Now the pressure head at point 2 will be P2 by gamma, the velocity head will be V2 square by 2g, and Z will be Z2. Now see, Z1 is 0, so I will take it as 0. Now see, there is no change in cross section, so I can say the velocity will remain same. So V1 is equal to V2, yes. So if you take a difference of this, what will happen? Then this will get cancelled with this one. Why? Because V1 is equal to V2 because the discharge will not change, and also the velocity will not change because area is not changing, right? So these two also will get cancelled. Okay. Now Z2 we have just got, right? Z2 how much I have got? 5 sine 45. Very good. So I can say that this particular thing will be equal to what? The total head loss in this particular pipe, right? Total head loss in this particular pipe. So I can say the total head loss in this particular pipe will be how much? How much I will get? It will be, you see, P1 minus P2. P1 is how much? 435. P2 is how much? 200. So I can say P1 minus P2 by gamma, and then what? Minus 5 by root 2. How this minus 5 by root 2 is coming? Because you see Z2 is what? 5 sine 45 means what? 5 by root 2. So I can say what? This is minus, so minus 5 by root 2. Okay, somebody has found the answer. Let us state that is correct or not. Very good. So now P1 minus P2. P1 minus P2 is how much? 235, right? 235 kilonewton per, I can say, meter square. Now see, the oil is having density of 800. So I can say that oil has a specific gravity of how much? 0.8. 800 by 1000 is what? 0.8. So if I want to get the unit weight, it will be how much? 0.8 into 9.81 kilonewton per meter cube, right? And then minus 5 by root 2. So what is the total head loss I am getting? Let us find out this. So this will be 235 divided by 9.81 divided by 0.8. So whatever I am getting, I'll subtract this 5 divided by root 2. So how much I get? 25.77. Oh, Rishabh, that's great. Pretty impressed by you. That's great. Very good. Very good. You have got the right answer of discharge. Very good. So 25.77 meter is what? I'm going 25.77 now, or I got something wrong answer. Let me just recheck. Nikki is telling 26.4, so I might have done some wrong calculation. So 0.8 divided by 9.81, okay. So whatever I'm getting, okay, minus 5 divided by root 2. Okay. 26.41 I'm getting, 27.4, sorry. Yes, this much. Now this head loss I will equate to the equation of head loss, that is how much? 32 mu, the average velocity into L by rho g d square, or I can say gamma d square. Yes, this is the equation, Hagen-Poiseuille equation. Yes. So from here I can find out the velocity, right? This is the average velocity I can find out. Yes. See, mu is given how much? Dynamic viscosity 0.8, and then d is given for the pipe 0.1 meter, and then L is given, length of pipe is given how much? It is given 5 meter from this point to this point, 5 meter. Okay. Let me put, so we put these values, okay. I am getting U bar how much? First of all, tell me the average velocity. From that we'll get the discharge, right? So it will be 26.41. Gamma will be 0.8 into, I can say, see I can use this gamma as rho g if I using rho g. So rho will be 800, okay, and g will be 9.81 I can use, and then d square 0.1 square divided by 32. Mu is given how much? Mu is given 0.8 again, and L is given 5 meters. So how much you are getting? U bar, the average velocity. Good evening, good evening. How much are you getting? 26.41 into 800 into 9.81 into 0.1 square divided by 32 divided by 0.8 divided by 5. Okay, 16.19. See, I have choose little difficult questions if you see, right? I have choose not difficult questions, conceptual questions, because in the GATE 2 mark questions you'll expect this kind of questions. So from now I will be solving little good questions, okay? Because in the examination they will ask you good questions only, like these questions they will ask you, okay? Which you cannot solve by just, you know, random 1-2 things. You need to be conceptual, at the same time you need to know the formula also. So upcoming times we will be solving such kind of questions. Very good. So from here I can find out discharge. Discharge is how much? Pi by 4 into d square, the area into velocity, right? So we put these values, pi by 4, then 0.1 square, and u is 16.19, I'll get the discharge. So you can see that I have mixed the topics. So 3.14 divided by 4 into 0.1 square into 16.19, I'm getting how much? 0.127 meter cube per second, yes. Very good. So like this, I have taught the entire fluid mechanics. It is available in the BYJU'S Exam Prep app. Okay, it is available in the BYJU'S Exam Prep app. Okay, and you can always see those lectures. Always see those lectures. Okay, let us go to the next thing. Okay, next question. 9th question. Okay, very good. So Venturi meter. Okay, Venturi meter. Okay, so Venturi meter is used to find out what? The discharge. And discharge is what? Discharge is the coefficient of discharge, okay, in Venturi meter equations, remember, A1 into A2 root under 2GH divided by what? Root under A1 square minus A2 square. That formula for finding what? Discharge. Now, this discharge equation is not affected that much even if the Venturi meter is inclined. So suppose this is a point 1, okay, and here you see the area is suppose A1. Is the point 2, the throat I can say. Here the discharge is A2. The discharge area is A2. Okay. So diameters are given, you see. This is, you can say D1 and this is D2. So you can always find out what? The areas. We'll see that how much areas we are getting. Okay. So when nothing is given about the coefficient of discharge, you should take that as 1. When nothing is given about the coefficient of discharge, that will be taken as what? 1. Taken as 1. Now what is this H? How to find out the H? You see, if it was only, you know, water, I can say I could have used directly what? This level difference HH. But it's not. We are using what? We are using a differential manometer. So whenever a differential manometer is used, means what? Actually this will be like this actually, right? Okay, and this portion is filled with mercury. Okay, this is mercury. This portion is filled with what? Mercury. Now when this is the case and this is the difference of levels, so how to find out the H, the actual head difference? The formula is X into what? The ratio of the specific gravity of the fluids minus 1. You see, this fluid is what? This fluid is mercury given now? 30 centimeter of mercury, so this is mercury. Yes, mercury specific gravity will be how much? It is 13.6. And we are measuring a particular oil actually. This is an oil. It is given blue. Some oil can be blue also. And this oil is having specific gravity of how much? It is having specific gravity of 0.8. So from this you can actually find out the head difference between this 0.1 and 0.2 by using this equation. Yes, and this will be X is how much? It is 30 centimeters, so I can take 0.3 meter. Then S2 is 13.6. S1 is how much? 0.8 minus 1. So how much actual head difference between this 0.1 and 2 I am getting? Okay, reserve has found answer discharge. Might be the right answer. Let us see. 13.6 divided by 0.8 minus 1 into 0.3. I am getting how much? 4.8. I am getting 4.8 meter. Now, rest of the things are very simple calculation. See what will be A1. A1 will be the area at, you know, section 1. That will be pi by 4. You know, diameter square. That is how much? Diameter is how much? 0.2 square. What will be A2? A2 will be pi by 4 diameter square. Diameter is how much? 0.1 square. These are what? A1 and A2. What? A1 and A2. So you can find out this A1, A2, right? Put here, H also you got, G can take 9.81. Yes? If you put all these values, getting discharge how much? 0.0787. Okay? If you put this, you're getting how much discharge? As ISRO has found out, that's the right answer actually. 0.0787 meter cube per second. Others are also getting, no, somebody is getting different answer also. So I have to find out. Otherwise, I can't trust you. I can't trust. But I feel that it is 0.0787. Okay, let me find out. And say root 2. Others can also calculate and tell me, is this correct or not? Normally I don't see the answers. Okay, I just trust the students. Other students are not calculating. They just want the PDF. Okay, Nikki has got. So two answers are matching. So I can say Q is equal to 0.0787 meter cube per second. Very good. Understood? This is how you find out discharge in a Venturi meter, and that can be for inclined Venturi meter or horizontal Venturi meter, doesn't matter. This is the way. So this is, you find out what? This, if it is inclined, you have a differential manometer. Okay. See, if it's not a differential manometer, only, we have only one fluid and it's open and, only the head difference, right, directly take the difference. How? In that case, S2 by S1 we can take, yes. No, not take 1. Okay, that I will tell in another lecture. Not here. Question number 10. Okay, something on hydrostatic forces also, right? Let us solve some questions on what? Hydrostatic forces. This is the last question. Okay. This is the last question on hydrostatic forces. So 10 questions we have solved, and rest 10 is homework for you. Okay. Some homework for you. See, question number 11, homework, answer is given. You can solve yourself. Question number 12, homework, answer is given. 13, question is given, answer is given. 14, question, answer is given. 15, question, answer is given. Okay, this is from, horizontal acceleration, fluid in horizontal acceleration. Then some pipe flow, question, answer is given. Yes. 17, also question and answer is given. Where is the answer here? Oh, answer is there. Yes. And then we have question number 18. Okay, manometry. The question answer is given. 19, the question is there. From buoyancy, answer is given. Question number 20. Okay, from your acceleration, pressure distribution, when you have, accelerating fluid, that answer is also given. Let us solve our last question of the day. Other questions are for your practice, and the answer is given so that you can solve. And I had not given the solution. Why? Because you have to solve yourself. Na? Everything I have solved in the class, then what you will solve? Okay. So here it is an inclined rectangular Swiss gate AB. So we have a inclined rectangular Swiss gate AB, 1.2 into 5 meter. 1.2 into 5 meter as shown in the figure. Okay, it's a gate. It's entirely a gate. Okay, to control the discharge of water. Okay, very good. The end A is hinged. So this is hinged. Very good. This is hinged. You have to find out the force to be applied normal to the gate at B to open it. Basically, you have to apply a force F here, and since it is hinged about this point, so if you apply this force, then it will get lifted like this, right? Right? So open the gate. So if you want to open the gate, you have to apply a force F here. So how much force F you have to apply? That is asked in the question. It is very easy. How to solve this question? You see, here what will happen? the fluid force will act. Okay, the force due to the pressure will act. Suppose that is the pressure, the force due to the pressure of fluid is acting at this point. So I can say that this is point A, yes, this is point B, okay, and then this is the F, okay, and this is what? FP, right? Something like this is given, yes. Now, it is hinged about this point. So if you want to open it, then this particular force will exert some moment about A, yes. So if you want to open this gate, what you have to do? You have to apply a force F in such a way, the moment of F, P, the moment of Fp about A will be equal to what? The moment of F about A. Understood? So when the moments are equal, yes, or just equal, then then it will get opened. This is the concept behind solving this question. Now, you have to find out this Fp, yes, and also this location. Then only I can take these distances, right? Because this is the lever arm. So to find out this location and the force Fp, we have to do some things. Now this is the pressure force. How to find out the pressure force? Very easy. That is gamma into H bar into A. It is the pressure force. Gamma into H bar into A. What is H bar? H bar is the depth of the centroid. Depth of the center of gravity of that particular surface, right? So this gate is an inclined surface, right? It's a rectangular surface given what? 1.2 into 5. So if you see, actually this will be like this, right? Like this. The gate will be something like this. If you see, it's something like this. This will be 1.2 and this is 5, right? The centroid will be where? The centroid will be at the center, right? It's a rectangle center. So I can say the centroid will be somewhere here. The centroid will be somewhere here. So I can find out the depth of this centroid. I can find out what? The depth of this centroid, and that will be H bar, and I can multiply the area. Area will be how much? Area is how much? Area can say 1.2 into 5 is what? 6 meter square. So this is the area. If I can somehow get this H bar, then I can solve this. I can solve this very easily. Let us solve. Diagram is there. So let us first find out H bar. How to find out H bar? I'll tell you. You see, this is exactly at the middle. So can I say, suppose this is G point. So can I say this AG will be equal to 0.6, right? This AG is equal to BG, both, right? AG is equal to BG is equal to 0.6 because it is exactly at the middle. So it is 0.6 meter. Okay. Now see, this is given as how much? Let me just switch off the phone. It is doing goo. Okay, now it will not do goo. Okay. So this is what? This is, I can say, is your 5 meter given in the question. This is 5 meter. Very good. Now see, you see, this is H bar, na? This is H bar. Very good. Now suppose this point I am calling as O. This point I am calling as O. Very good. Now see this triangle BGO, right? This BG is 0.6 meter. Yes. And this is 45 degree, means this also will be 45 degree. Yes or no? 45 degree. Yes. So can I find out OB? Can I find OB? Yes. If this is 0.6, I can say OB will be equal to what? 0.6 by sine 45, right? It will be 0.6 by sine 45. So what will be this value? This will be 0.6 by sine 45 means 1 by root 2, giving means what? 0.6 root 2. No. This will be 0.6 by sine 45. So why I am getting this? What will be this? I can say sine 45 will be equal to your OB by BG. It will be into actually, right? It will be into. So 0.6 sine 45. Yes. So this will be 0.6 into sine 45 will be how much? 1 by root 2. So how much I am getting this OB? OB how much I am getting, tell me. How much I am getting OB? OB will be equal to your 0.6 divided by root 2. I am getting a value of 0.424. Okay, I am getting a value of what? 0.424 meter. Are you people solving with me? Are you people solving with me, or you are sleeping? Slept? Wake up. Okay. Now, see this. Can I say this H bar? If this is H bar, this is also H bar, right? You see? If this is H bar, this to this is also H bar, right? Can I say from this diagram, this H bar is nothing but 5 minus OB, na? This 5 minus OB, na? So how much I am getting this? This I am getting 5 minus 0.424, that is equal to 5 minus 0.424, that is actually equal to 4.576. So everybody understood how I am getting this H bar. Yes, how I am getting this H bar. So how to find out pressure force now? Very easy. This fluid is water, right? This is water. Okay, this is water. So I can say gamma W into H bar into area. So gamma W I can take 9.81, H bar I can take 4.576, and area how much I will take? Area I will take 6, 5 into 1.2. So how much pressure force you are getting? Tell me, what is the pressure force? It will be 9.81 into 4.576 into 6. I am getting a value of 269.34 kilonewton. Yes, kilonewton. This is the pressure force. So you got the pressure force. Very good. So erase these things. Erase these things. Okay. We got the pressure force. But does the pressure force act at the center of gravity? Tell me. Where the pressure force acts? Tell me. It acts at the center of gravity or some other location? Tell me. I want to see. Where the pressure force acts, it acts at the center of gravity or some other place? Where it acts? Where the pressure force acts? Tell me. Nobody is telling. Why nobody is telling? Okay, don't know. It acts in the center of pressure. Forgot. Okay, forgot. It acts at center of pressure. Okay, below, but where exact? The name is center of pressure. So it acts at center of pressure. Okay, and this depth is known as what? This is known as the depth of center of pressure. Now, how to find out this depth of center of pressure? The depth of center of pressure is actually equal to the depth of center of gravity plus the moment of inertia about the center of gravity into sine square theta, where theta is the angle of inclination of that particular inclined surface, divided by area into h bar. Area into h bar. Very good. Some people have told center of pressure. Okay, very good. Now HP will be equal to h bar. We know h bar we have already got, right? 4.576. Very good. That we know. So 4.576. Now what is the moment of inertia of a rectangular area? It is B h cube by 12, right? So I can say it will be B or BD cube by 12, I can say. So it's BD cube by 12, sine square 45. Now what is the area of a rectangle? It is B into D. So it is B into D and divided by h bar, which is 4.576. Now see what will happen, this B get cancelled, I get a D square, right? Now D is how much? It's a rectangular area, right? Rectangular area, the D is given as 1.2 meter. Here you see it is 1.2 meter and this is 5 meter. Okay, so take this D in this direction actually. Okay, so I can say this is 1.2 meter, okay, square. So how much I am getting this? Tell me. HP, how much I am getting? Tell me. It is how much? Tell me. Just put the value of, here you can just eliminate everything. I'll get D square by 12. So I can say this is 1.2 square by 12. So what is the answer of, center of pressure? See, the examination, they can ask you only the center of pressure also. So what is the depth of center of pressure? Tell me. How much? How much you getting? Very good. 4.589 meter. 4.589 meter I am getting. Very good. Good students. Okay. So we got our depth of center of pressure. Yes. And at this point only your FB will act. Okay. But I was interested in finding this what? But it will act like this. I was interested in finding the force to be applied at B to lift this particular gate. So what I will do, I'll just draw a bigger diagram. This is the gate A point where it is hinged. This is the B point where I will apply what? Where I will apply the F force. And I got my FP. I got my FP, which is 269.34, right? I got this. Okay. Now see, this distance of B from A is how much? This distance is how much? See, when I am finding the moment, when I am finding the moment, yes, I will take distance AB for moment. So I can say this F force will be having moment how much? F into AB. AB is 1.2 meter. Now, this FP force also will generate moment. That will be what? F into this distance. This distance, right? Now, how to find out this distance? How to find out this? You can find out, see. You see this. This is this distance, right? This is this distance, right? Very good. Now see carefully. Now see carefully. This is HP and this is 5 meter. Yes. Now I will take another rectangle here, triangle here, you see. I'll take another triangle here. And people think gate is easy. People think gate is easy. They will just solve, you know, sigma 1 minus sigma 2 by 2 is radius of Mohr circle and you feel that I have cracked gate. That is not possible. Or suppose you have just found out Froude number and you feel that I have cracked gate. Or you know, I just found out index now, plasticity index, liquid limit minus plastic limit or something like this. Not happen. If you don't solve questions like this, then you will end up with 30 marks, 40 marks, and then you will continue that cycle of giving gate every year. So you have to solve questions like this. Yes. So FP into this thing. Okay, let us see this. This is this triangle. Okay, let me take this point as Q. Suppose this point as P. Okay. Now see this triangle. Now see this triangle. Okay. This is B, P, Q. Right? B, P, Q. Can you tell me what will be this BQ? Yes, it is easy, right? Can I say this will be 5 minus this HP now? Yes, you see? This BQ will be equal to, you see, this will be 5 minus your HP. How much? HP is this one. Can I say it will be equal to 5 minus 4.589. That is how much? 0.411. That is how much? 0.411 meter. Easy. Yes, 411 meter I got. No. Yeah, 411 meter got. Yes. Now from that, can I find out BP? Yes. This is what? Theta is equal to 45 degree. Yes. So I can say that your sine 45 will be how much? It will be BQ by BP. Yes. So from here, BP will be equal to how much? BQ by sine 45. That will be equal to 0.411 into root 2 because sine 45 will be 1 by root 2. So root 2. So I can say I will get a value of 0.581. I'll get a value of how much? BP as how much? 0.581. If I get this as 0.581 meter, then what is this PA? What will be this PA? Can I say it will be 1.2 minus 0.581, right? Yes. It will be 1. Am I getting this value? Are you all getting these values? Are you getting all these values? Very good. 581, right? Let me just recheck the concept. 5 minus HP, yes. Yeah. Yes, I'm getting 0.581. So I'll get how much value this AP. This AP, how much I will get? 1.2 minus this 581. I'm getting a value of 0.619. Yes. This AP I am getting how much? This AP I am getting how much? 0.619 meters. So I'll equate this. Now I can solve this question and find out what? F. So F will be equal to 269.34 into 0.619 divided by what? 1.2. Let's solve this question. I'm getting 138.9. Has anybody found? Okay. Rishabh has found almost the closest answer. That means some calculation here and there. So 139.93 kilonewton we are getting. Okay. 138.70. Understood everybody how we solve this question? Yes. How we solve this question, have you understood? Yes. So this type of questions you need to practice. So this 2020 series was to make you aware of the level of questions which they can ask in the upcoming GATE examination 2023 or 24. Okay. So they will be asking you questions like this. These are what? These are all 2-mark questions for your upcoming GATE examination. So the homeworks are given. Okay. Homeworks are given. And if you feel that what to do now, you're getting confused by seeing the level of the questions, right? You might be thinking that, sir, I will do sigma 1 minus sigma 2 by 2. I'll find out the radius of Mohr circle. I'll get 80. No, that will not happen. So if you are confused what to do, you can always contact me. This is my phone number, 8826 726 300. You can contact me. I'll guide you that what to do, what not to do, at what stage of preparation you are. Okay. So please contact this on this number, and upcoming lectures also will be there. Okay. So hope you enjoyed these particular lectures on fluid mechanics, where we solved the standard 2-mark questions which can be asked in the examination. And I am telling you, 20 questions can never be enough to crack GATE. You have to solve minimum 500 questions per subject. But yes, those 500 questions start from one question. Yes. Thank you very much. See you next time.